Section 6.3 is tests for parallelograms. So what information will we have to know about a quadrilateral that would make the quadrilateral a parallelogram? First theorem. If both pairs of opposite sides of a quadrilateral are congruent, like so, then the quadrilateral has to be a parallelogram. So in this case, parallelogram scab is a parallelogram. If both pairs of opposite sides are congruent, then the quadrilateral is a parallelogram. Next theorem. If one pair of opposite sides in a quadrilateral are both parallel and congruent, then the quadrilateral is a parallelogram. Next theorem. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So if this segment CM is congruent to MB, and segment SM is congruent to segment MA, we can conclude that this quadrilateral is a parallelogram. Next theorem. If both pairs of opposite angles in a quadrilateral are congruent, then the quadrilateral is a parallelogram. So we can see the opposite angles C and B are congruent. Opposite angles A and S are congruent. Therefore, the quadrilateral scab is a parallelogram. Some examples. Determine if each quadrilateral must be a parallelogram. So looking at this, we have this half of the diagonal is the same length as this half, thus the name half. This half is the same as this half, thus the name half. Then that makes this a parallelogram. To determine if it is, we're going to say yes. Why? The diagonals bisect each other. We would like to name a theorem, but the theorem that we use for this doesn't have a name. So we just basically say what in the theorem makes it true. Number 2, this is basing it on the theorem that if both pairs of opposite angles are congruent, then it's a parallelogram. We have one pair of opposite angles the same. We have no idea what's happening in these angles. So this one is a no. Number 3, is this a parallelogram? You betcha. Opposite sides are parallel. So this is a parallelogram by definition of a parallelogram. For 4 and 5, use the parallelogram and the given information to find each value. So we know it's a parallelogram, opposite sides are parallel, and there's lots of other facts we could add to this. Measure of angle ABC is 50 degrees. Find the measure of angle BCD. This goes back to the previous section. Measure of angle ABC plus the measure of angle BCD is 180. Consecutive angles are supplementary. So that's 50 plus the measure of angle BCD is 180. Thusly, the measure of angle BCD is 130 degrees. Number 5. AB is 11. BC is 2. Measure of angle ADC is 84 degrees. Once again, it's a parallelogram. In a parallelogram, opposite sides are congruent. So AB is going to be equal to DC. AB is 11, therefore DC is also 11. On the flip side, what values must x and y have in order for the quadrilateral to be a parallelogram? we're told that ST is x plus 3y, that TA is 6, and that PT is 4x plus 2y, and that TN is 14. Well, these are relating to parts of diagonals. So according to one of the theorems, if the diagonals bisect each other, so if those segments are congruent and these segments are congruent, then that's going to make this a parallelogram. So ST has to equal TA, so that's x plus 3y equal to 6. In addition to that, PT has to equal TN, means 4x plus 2y has to equal 14. If we take those two equations and put them together, that's solving a system of equations, which we spent a little bit of time on at the beginning of this chapter, reviewing that from algebra. Get one of the variables by itself in one of the equations. Getting x by itself is going to be pretty easy in this red equation. I'm going to take my blue equation and I'm going to replace the x in it with a 6 minus 3y, because that's what it's equal to. Distribute the 4 using the distributive property. We get 24 minus 12y plus 2y equals 14. Combine like terms, we get 24 minus 10y equals 14. Subtract 24 from both sides, you get minus 10y equals negative 10. Therefore, y equals 1. We go up here and replace the y with a 1. Simplify it. We end up with the ordered pair 3, 1. The directions asked, or the question asked, what values must x and y be in order to make this a parallelogram? X has to be 3 and y has to be 1. This next problem. The coordinates of the vertices of the quadrilateral are given. Determine if the quadrilateral is a parallelogram. Well, the first thing you have to do is determine if this, in fact, is a quadrilateral. What do I mean by that? Make a quick sketch of this. A is negative 1, 3. B is 2, 1. C is 9, 2. And D is 6, 4. If you connect them in order, A, B, C, D, you should get a four-sided figure. If you don't, you can stop the problem and say, this is not a parallelogram because it's not even a quadrilateral. Once you've determined that, then you got these 4 choices to do this problem. Option 1. You could use the distance formula to find the length of all 4 sides. And then there's a theorem that says if opposite lengths are the same, then it is a parallelogram. So it's one choice. Distance formula 4 times. Second choice. Use the slope formula to find the slope of all 4 sides. The definition of a parallelogram, if opposite slopes are the same, then it's a parallelogram. So option 1, find the distance of all 4 sides. Option 2, find the slopes of all 4 sides. Option 3, find the slopes and lengths of one pair of opposite sides. You'll be doing the distance formula twice and the slope formula twice. If the pair of opposite sides have the same slope and length, then it's going to be a parallelogram. Option 4 is my favorite. Find the midpoints of the diagonals. If the midpoints are the same, that means they bisect each other and it's a parallelogram. So that's the option that I'm going to choose for this. I'm going to choose option 4. Just have the points written down up here. So let me bring my picture back that I had. Another reason why this picture is important, you want to know what your diagonals are. So I'm doing option 4. I'm labeling that just so you know when you look at your notes that's what's happening. Option 4, I want to know, is the midpoint of segment BD equal to the midpoint of segment AC? If it's equal, then that makes this a parallelogram. If they're not the same, then it isn't. So the midpoint formula, I sum the x values and divide it by 2, followed by summing the y values and divided by 2. My x values for b and d are 2 and 6. My y values for b and d are 1 and 4. Two plus 6 is 8. 1 plus 4 is 5. 8 divided by 4 is 2. 5 over 2 doesn't reduce. The midpoint of diagonal BD is 4, 5 halves. Now I'm going to see if the midpoint of the other diagonal is the same. So the midpoint of segment AC. I'm going to sum the x values divided by 2. I'm going to sum the y values divided by 2. The x values for segment AC is -1, 9. The y values for A and C are 3 and 2. Just adding them together and then dividing them by 2. It's going to give me 8 over 2 and 5 over 2, which reduces to 4 and 5 halves. So check it out. The midpoints are the same. If the midpoints are the same, it means the diagonals bisect each other. So the question was, determine if the quadrilateral was a parallelogram, and we're going to say ABCD is a parallelogram. Then we're going to say why, because the diagonals bisect each other. Had we used a different method, we would have a different reason. That concludes that problem. That concludes these notes. Please do the 6.3 homework.